Okay, hello. This is the XPRIZE OSU FABE SAS3 lab that is in the competition for the Wendy Schmidt Ocean Health XPRIZE. I want to give you a brief description of our sensor and what it looks like so that you have a good opportunity to see what it is. And now I have an example of the sensor right here. This essentially consists of a chamber housing which has seawater within it, or is intended to have seawater, and there's a membrane within there, and there are several membranes which filter ions and allow a hydrogen ion current pass when we pass an electric current through this. Now here's a device where we have an electrode which is inserted like so, and we will insert it entirely when we're ready to deploy it, and here's the other electrode. So now in between these two sensors, the current that flows is filtered by the membrane, and you have a hydrogen ion current, and that is proportional to pH. That's the fundamental principle which we have previously published, and we've also have a patent on. Now, there are some modifications between this device, between the original device and this device. The original, we had everything enclosed. In the current device, we have to allow some flow of seawater to respond to the changes. And this entails a bit of a design complication or sacrifice, because we need to enable seawater to flow in and out, but yet we don't want leakage current to go past the membrane and come back and corrupt our reading. And hence you have these tentacles that are little tubes that allow some ingress of seawater, but also provide a long current path so that you're actually restricting the amount of leakage current. This is the basic design sacrifice. This is something we hope to optimize in the months ahead to be able to ensure that more seawater flows in. The sacrifice means that our seawater flows in rather a little slowly, and therefore we need to allow enough time for equilibration with a new seawater environment. In any event, normally this sensor is stored under seawater because the space between the membranes also has seawater at this point. And so it's always stored under a seawater environment. That's as far as the description of the sensor itself. Now, these sensors are going to be deployed, and we'll have a separate deployment video where you can view this. But this is the electronics end of the device. We have a housing here, which is cylindrical and is intended to withstand pressures in the deep ocean. And we have here several components. Our instrumentation and power supplies will be housed within there. And essentially this end consists of the data logger, which is within there, and a battery. And so the battery supply and the data logger all are inserted within this chamber, and we will provide all the detailed instructions. But essentially the end piece is then used to close the entire device, and all it takes is a little bit of pressure, and we will illustrate that a little bit later. The other end, and I have my associate Brian Heskett here, our team member, who is illustrating. We have a pressure transducer here and several thermocouple wires. All of these are sealed, and the thermocouple wires are intended to measure the temperature of the ocean. The pressure transducer will measure the pressure at whatever depth we have. And so this entire assembly is closed and will be used for deployment in all sets of conditions. When we get to the deployment video, you will see that we will house all our sensors down in this space underneath so that they can be submerged into seawater. Okay, thank you. Okay, this module will relate to how to deploy and program the data logger, and essentially preparation of the electronics prior to the actual deployment of the sensors, which are going to go down here below. So we will do that in a separate video. Now, if we actually start, we would ideally like to open this, and this is how you would receive it. If you need to, we have these little tools, if you will, that will enable you to open the end of this device. And once this slides out, we are now able to access the electronics. And let's note here there's a battery. Okay, and the battery is chargeable. Okay, normally we will provide it to you fully charged, So let's suppose for some reason it was not. This is entirely chargeable by simply plugging in and plugging into the charging port. And once you notice the green light, it means that charging is going on. Once the green light is off, the charging is done, so there's no need. So this is a fully charged battery, which should not have any issues with it. Now we're going to connect this back up to the data logger. And now I'm going to pull out the data logger, and all you need to do is to pull out the data logger sufficiently to expose the serial I/O port, and the I/O port, we will then connect up a cable from the laptop, which we will be providing you, with the serial I/O port to this data logger. And once we've done that, we are now ready to actually start loading the program. First, we're going to power up the system, so we'll turn on the battery on the on position, and you notice a little red light which shows that it is indeed on. Okay. And so this is our first step. Now we will move to the downloading of the program to the data logger.
Okay, on the computer, there's a folder on the desktop called XPRIZE, and that's where we will keep our programs, and you can store all of your data, so it's all in a central location. The program we use to communicate with the data logger is PC200W, so I will double click on that. And the first thing we do is we click connect to the data logger. And it is connected now. Before we send the program, though, we should make sure the time in the data logger is the correct time according to whatever time base the judging staff would like to use. So down here in the corner, you double click that, and you can adjust this time to whatever, again, whatever time base you prefer. So do that. I'll click apply. Okay, so now this is set correctly. So now we need to tell the data logger that's the time. So you click set clock, and you notice the data logger then updates to the same as the computer. And now all we have to do is send the program. You click send program. Here's a warning that it'll overwrite all of your data, which is fine because there's no data on it. Click yes. Right now it's coming up in the right directory, but just in case it comes up in a different directory, just go to desktop, XPRIZE, programs, and then I will label the programs according to the phase of the competition. So far, all I have in this directory is the 2A, so this is for the phase 2A. But when you run 2B, 3, etc., you just pick the program that corresponds to that phase of the competition. So you double click that, and program was successfully sent. Click OK, and that's really all we need to do with the computer. We can close this. It says you're currently connected. Disconnect. You say yes, and we are done with the sending the program.
Okay. Now we are ready to close up the system, so we disconnect the serial I/O port. We push back the data logger into the enclosure, and also the battery pack. Taking a little care to be gentle about this, because we want to be sure that we don't disrupt any of the connections. So once this is in place, we can replace the end piece, and this can be pressed in with a little bit of pressure and by twisting slightly. And it would be a good idea to push on both ends of this, and one can essentially close this up without too much effort. And now essentially the data logger is collecting data, even though the sensor is not deployed. When we get to the sensor deployment, you will deploy the sensor in there, and put the entirety of these contents into the environment where you want to test it. Remembering, of course, that the initial part, all that time lag, there will be no real data collected until the sensor is in the water. We will deal with the issue of the data that comes out at the beginning when we talk about uploading the data later. Okay? Okay, now.
Okay. Okay, so we have retrieved our sensor from the test fluid, and we've already removed the actual sensor, and we've stored it according to protocol. And now it's time to get the data out of the data logger. So again, to remove the cap, you can use these to pry, or usually it's actually pretty easy just to jiggle and twist. And it comes right out. Okay. Please note the battery is still on. Do not turn off the battery until you get the data, because the data logger loses all of the data if you turn off the battery. So put the battery down. Slide out the data logger enough to expose the serial port. Connect the serial cable. Again, don't turn off the battery. Come over to your computer. Once again, we use PC200W. Okay, it's up. And the first thing we need to do is connect to the data logger. And we are connected. Now, we need to go to the tab here at the top called Data Collection and click on that. And this brings up this page. We want new data from data logger, and we want it from final storage area 1. And to specify your file, you click on this little square with the dots. That brings up a dialog box. It's already in the correct directory, but in case it isn't, for whatever reason, you can go to Desktop, and then again to XPRIZE, and again to Data. And here's previous data files that we have. You can go ahead and give it your own name. I'll call it Test 8, but you can call it whatever makes sense, 2A data or whatever you would like. Click Save. That saved the actual file that's going to be stored, but we still don't have the data. We have to, the last thing we have to do is start data collection. Click that button, and it brings up a dialog box showing you got it from storage data 1, has the output file name and output format and all of that stuff. So that shows we do actually have the data file, and so we are done getting the data. And close that, and we're really done with PC200W. Click that. Again, it asks disconnect and exit. Say yes, and we are done.
Okay.
Okay, so we have the data off the computer. Now for storage, we can disconnect the serial cable. Since you have the data, we can now turn the battery off. And we can just slide this in as we have in the past. Put the lid back. And now it's ready for storage. Unless, of course, we would want to take the battery out probably and charge it, but we will probably do that and then just give it back to you. Okay. Okay, so we have completed putting the data logger in the electronics chamber, and the program is on it and is running. And so now we just need to prepare the pH sensor for deployment. We have a frame that we're using to hold it. It's holding a conductivity sensor, which will already be mounted, and the wires for both sensors will come through the hole on the end of this framework. So now we can put the pH sensor into this frame as well. We have 2 electrodes which need to go through the hole on the end. And then we get the pH sensor out of the buffer solution and take it over here. We put the electrode in the end. Slight twisting motion helps it go in. Same on this side. And now we want to slide these little wings into these tubes on the sides, like so. And that holds this vertical like this. It's important that these tubes be vertical so that when we put it in, the air can evacuate out and we can fill up this chamber with the fluid to be tested. So now these sensors are ready to be placed in a nylon bag. This is a fine mesh nylon bag used to keep out barnacles. We slide it on the end. As we slide this way, just take some care to get it around any obstacles. There's a little bit to that. There we go. It's all the way on. We can put the end cap on. Good. So now we want to mount this under the electronics chamber by this bar that I was talking about. We slide through here. There's clips on the front and back, so I'll clip the front, and the back is clipped.
Also, just a note to make sure that the tubes are pointed upwards, so that bar and its location in relation to the pH sensor is very important. Make sure that they're indeed vertical, otherwise the system will not charge.
Okay, and the last thing to connect is these are the leads going into the electronics chamber, and they will only go in one way because of this locating pin. So you line it up and just push straight in. And now slide the retaining sleeve up here, tighten that down, and it is ready for deployment. So these are temporary handles. We'll have better handles on it when it comes to you. You can lift the unit, take it to your test fluid, and lower it in. So, once it's in, if you could just rock just a tiny bit to help just get the last bits of air out of the pH sensor, and that is fully deployed. And this is the procedure that will work for all phases of the competition.
We are. These are special instructions only for Phase 2A. In Phase 2A, as I note from the instructions, you're planning a change of pH and determining the response of the sensor. Because as I've explained it already, because of our design choices, we would prefer to speed up the response of the sensor, and it's possible to do so if one follows a simple procedure. The response can be improved by taking the sensor out of the water, as Brian will demonstrate here. This enables our sensor to completely drain itself of the previous water that it contained. Hold this for about 10 to 15 seconds. Then lower it back in slowly into the water. And after doing so, it's a good idea to implement a slight rocking motion. This is what we did the first time to enable the water to come back into the new water to replace the old water, and also for air bubbles to escape from within the sensor. And when this is done, this improves the response of the sensor significantly. This is only for phase 2A, and I think that probably should be sufficient. For all other phases, there is no need to do this because these are longer duration tests, and eventually new seawater diffusing in will change the response of the sensor. But the sensor response will be slow because of the design choices we've made. And so this is a way to speed up the response of that sensor.
Okay, once the test is over, we can recover our sensor from the test fluid. We can simply lift it out. Let it drain a second. Okay. On the table. First thing I'll do is remove the cable, loosen the sleeve, and again pull straight out, jiggle just a little, don't twist, and there, that is done. And now we can remove the sensor frame, opening the clips front and back. We can remove the cover. And carefully pull the framework out, watching for parts that can catch on it. Careful to get that around those obstacles. There we go. Now to recover the pH sensor, you do basically the reverse of your assembly. Pull that out like so. And then you can pull the electrodes and place that back in the storage buffer. And we can go ahead and pull these electrodes back out. And that's it. The whole thing is ready to go into storage. So the next video will show you how to recover the data from the data logger.